Hi everyone, welcome to Tutoring Tuesday. It's Kristen here, and I am going to share with you tonight multiplying fractions, and we're specifically going to be focusing on multiplying a whole number by a fraction and then multiplying a fraction by a whole number. And so one thing that I really want to make sure that we address tonight is the fact that we cannot just jump to the procedure of what we learned. So how I learned how to multiply fractions was I just kind of multiplied across. I had no idea what I was doing, although I got to the right answer. But half of what we really want to make sure that our students understand is the process in which we arrive at the correct answer. It's not just all about the correct solution, but truthfully, it's about the process and truly understanding what multiplying by a fraction really means, or multiplying a whole number by a fraction or a fraction by a whole number. And so spending time and talking about what is happening in multiplying by a fraction, a whole number by a fraction, or a fraction by a whole number is truly where learning occurs. And so if your kiddos come home or your students question you, just remember, what do we know about multiplication? It's all about equal groups, right? And so I'm going to teach you some really concrete and conceptual visual models that will really help you understand multiplying fractions. If you're anything like me, I was like, oh my gosh, this makes so much sense. But ultimately, it will help your kids at home and in school if you are a teacher watching. So hopefully you find this helpful. And if you do have any questions, make sure you post below. And if I mention anything specific, I will make sure that I put it in the comments, like fraction towers or tiles. I'll put a link to Amazon just to show you what I mean by that. And then I will also post my YouTube channel after I upload this to YouTube. So, all right, you guys ready? Here we go. Let me turn you guys all around. All right, so the first one that we're going to be looking at is multiplying 4 by 1/3. And I really want us to think about what this truly means. So what we're really doing here is we're trying to determine how many 1/3 pieces fit into 4 wholes. It's just like multiplication, what we've learned about multiplication and making equal groups. We're trying to figure out how many equal groups of 1/3 fits into 4. And so what we do is we, show students how to build this, which I'll show you with visual models, but I'm going to show you a visual model that really relates to how we teach concretely in school. So we want you to think of what we're starting with. So we're starting with 4 wholes. So I'm going to break this up into 4 wholes. I'm going to label it as such. 1, 2, 3, 4. And what are we truly figuring out here? We're figuring out how many 1/3 pieces fit into 4. So let's do it. So I'm decomposing or partitioning each of my 4 wholes into 1/3 or thirds. And now my job is to determine how many 1/3 pieces fit into 4. So I'm going to take each 1/3. That's 1/3. 1/3. 1/3. And 1/3. And what students will start seeing is that there's 1/3 in the number 1, there's 1/3 in 2, so therefore there must be 4 thirds in 4 wholes. What you can then do in order for students to start seeing what this means, and also to keep in mind, this is an acceptable answer in grades 4 and 5. We're not simplifying fractions. We're really just getting the conceptual understanding that there are 4 thirds. We are not asking them to simplify by any means. So I'm going to go back to our visual model. Here are our 4 wholes. Each whole is broken up into thirds, and our job is to find out how many 1/3 pieces fit into 4. And so what we can see here is that there's 1, 2, 3, 4, and then I can condense that to 4 pieces, and I can see that it equals 1 and 1/3. So this is otherwise renamed as 1 whole and 1/3. All right, let's try another. So this one, I don't know why 4 is my lucky number today, I guess. this time we're trying to determine how many 2/3 pieces we find in 4 holes. So once again, our visual model. I'm going to show you actually a visual model where you have 4 all together, but then you have 4 separated too, so that will help you. So here's my 4. 1, 2, 3, 4. I'm going to actually extend those so that way kids can really see. My job is to determine how many 2/3 pieces fit into my 4, so I need to partition these into thirds. And then from there, I'm finding 2/3. Here's okay. All right, are you ready? So we're going to count 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, and 8/3. So there are 8 thirds that we see here. Let me show you that if you partitioned or if you took 4 holes separately. So a lot of people like to do 4 holes separately, which is completely up to them. So here's my 4 holes. I know I'm going to try to determine how many 2/3. Okay, and then from there, I can determine 1, 2, 2/3, 2/3, and 2/3. And the same thing, I can then simplify this if I wanted to. And then you can see that there's 1 hole, 2 holes, and 2/3. So this is renamed as 2 and 2/3. So this visual fraction model really allows you to multiply a whole number by a fraction in a visual way. Let me show you this using a number line. So actually, let me do a number line after the next one. Let's do the number line after the next one. All right, so that's multiplying a whole number by a fraction. Let's now do multiplying a fraction by a whole number. So what this truly means to me when I look at this is that I'm seeing groups of 2/3 and I'm seeing 3 of them. So ultimately my first reaction is, well, can I just say 2/3 plus 2/3 plus 2/3, which would give me 6/3? Yes, I can. That's called repeated addition. This is how we learned to multiply, by repeatedly adding equal groups of 2/3 3 times. So that's one strategy. Now, the way we were taught to just multiply across. We really want to make sure that we stay away from that because ultimately the procedure will not address truly what we're doing here. I also want to explain to students that that whole conception of I guess multiplying is creating a larger value really is false or expires when we multiply by fractions or decimals or anything of that sort. Because ultimately what's happening here, if you think about it, we're taking 4 and we're multiplying it by something less than a whole. So if we know 4 times 1 is itself, anything less than a whole has to be less than what we start with. And so that's a tough skill for students to understand. If we start with multiplication by saying every time you multiply you get larger and every time you subtract you get smaller or divide you get smaller, because those will expire when it comes to multiplying or dividing by something less than a whole, such that of a fraction or a decimal. So just be cautious of that. When you're teaching that, even as early as kindergarten, every time you add, you get bigger, because that is false when you start adding by negative numbers. Okay, so let's go back to 2/3 3 times. Another great strategy for us to just talk about is we want 2/3 and we want to show it 3 times. So I'm going to show my partitioned, and I know that I need to do this 3 times. So I'm going to shade this in so that you guys can see. Here's one group of 2/3. I know I have to go over to the next hole because I only have 1/3 there. Let's do this in blue. This is 2 groups of 2/3. And this is 3 groups of 2/3. So I have 2/3, 2/3, 2/3, and 3 of those 2/3 equals 2 wholes, otherwise known as 6/3. So this visual model allows students to see that how we are repeatedly adding 2/3, but more in a visual way. This is definitely more abstract. So if your students are very visual, which I highly encourage you to make sure that they see, is that you're adding 2/3, 2/3, and 2/3 in order to come up with or arrive at 6/3, or otherwise known as 2 wholes. Another great strategy if your students are number line kiddos, you're just determining how 2/3, and you're doing it 3 times. So we're going to start at 0, and I know I'm going to partition into thirds. So here's 1/3, 2/3, 3/3, otherwise known as 1. 1 and 1/3, 1 and 2/3, 1 and 3/3, otherwise known as 2. And obviously you would keep on going. But for the sake of this, I know my answer, so I'm going to show you when I find, here's 2/3 right here. Here's 1 and 2. 1, 2/3, so that's one group, that's 2 groups, and then 1/3 and 2/3, and there's my other third group. So the number that I land on my number line is 2. And I just did the same thing as I did here, repeatedly added 2/3 3 times in a visual way, and now in a number line visual. So let's try this again. Once again, we're starting with something less than a whole, and we're multiplying it by something of a whole number. So what this means is that we have groups through 4 groups of 3/5. Okay, so we have 4 equal groups of 3/5. Once again, in my mind, I think of repeated addition. So I think of 3/5 plus 3/5 plus 3/5 plus 3/5, and I add those up, and I know my doubles, so 3 and 3 make 6, 6 and 6 and 6 makes 12/5. For the sake of 4th and 5th grade, this is okay and acceptable to leave. My next one is a visual model. So what I'm going to do is I'm going to repeatedly add 3/5 4 times. So I know in my whole I need fifths. And I'm probably going to have to go above my whole, right? So let's do 3/5. 1, 2, 3. That's one group. 1, 2, 3/5. That's 2 groups. 1, 2, 3/5. That's 3 groups. Let me make my one more because I need to get one more group of 3/5 in there. And 1, 2, 3. That's my 4th group. I have 1 whole, 2 wholes, and 2/5. So my answer is 2 and 2/5. Likewise, we can do this on a number line. So you're going to partition the number line into fifths. And what I really like to do is just get the kids to at least do to the number 3. So 1/5. And I always have them label so that they know exactly what they're doing. And I am not one to consider this wrong. I just like to also rename that as 1. And the students start getting in the habit of seeing that as well. So that's 2. 11 and 12/5. Okay. So now I'm going to do 3/5 4 times. So I'm going to count 1/5, 2/5, 3/5, 4/5. That's one group. And I can circle that if you want to. That's one group. 1/5, 2/5, 3/5, 4/5. That's a second group. 1/5, 1/5, 2/5, 3/5, 4/5. And that's a third group. And of course, I counted by 4/5 instead of 3/5, so sorry. So 1, 2, 3, that's one group. 1, 2, 3/5, that's two groups. 1, 2, 3/5, that's four groups. And 1, 2, 3/5, that's my fourth group. So sorry about that, guys. So you can see that you can do truly any of these strategies and arrive at an acceptable answer. So it just depends on where students are at. If they are very much into the repeated addition, please do not stray them away from that. That's great. Eventually, we want them to see how that repeated addition lies within a visual model. So making that connection between where are my 4 3/5 here, and making sure that they're labeling that, and then ultimately your number line. Excuse me. So once again, remembering that multiplying a whole number by a fraction, remembering that what are we starting with? 4 wholes, and we're determining how many 1/3 or how many fraction parts fit into that one whole or number of wholes. And the difference here is that we're determining how many equal groups of that fraction do we have, and then therefore how do we rename that? All right, so hopefully you found this helpful. Let me just turn you around. Excuse me. So remembering not to just jump right to the procedure, making sure that we're taking time and making sure students truly understand what it means to multiply by fractions, either a whole number by a fraction or a fraction by a whole number. All right, guys, remember, have a great night. Math is great. Math is beautiful. Have fun.